We first made a toy plane, but we had difficulties at the moment that we made the molds because we needed to change the radius. Then we made a thick plane, but it was too big and ugly. Finally, we made a mold to make chocolate flowers because it was easier to design and also smaller, which means less machining hours. When making the flower, we had to design one petal in a scoop. Then the petal was copied and rotated to form a flower. We made a ball in the center and then we added a prince in the middle of the flower. Each part of the flower was joined. We used a thickness of 1 millimeter and finally we cut the piece.
First, we designed the positive and negative molds using the boundary tool. We added a flat surface to the flower mold for making an electroerosion later on. At first, we adapted the setup for the cutting machine. With this, we had to use an 80mm face tool leaving zero stock. Then we made a 2D adaptive only on the flat surface with a flat tool of half an inch, leaving 0.35mm of stock. For the roughing of the flower, we used an adaptive tool with a flat tool of half an inch, also leaving 0.35mm of stock. For the finishing, we did a scallop with a ball tool of 3/16mm, leaving zero stock. And finally, with a flat tool of half an inch, we made the finishing on the flat area. This mold was made in the Hyundai Kia machine. At first, we made a facing with a flat tool of 1 inch. After that, we applied a 3D adaptive with an end mill of half an inch, leaving 0.3mm of stock on the flower. Then we added a parallel of a ball tool, 1/4 of inch, on the flat surface of the flower, also leaving 0.3mm of stock. And finally, with morphed spiral with a ball tool of 3/16 inches, we did the finishing. We tested the program and generated the code. After adapting the code for each machine, we put the raw material on the milling machine, set the 0 point, configure the machine for receiving the program. Once we finished that, we upload the code from the computer to the milling machine and waited for it to finish it.
We had some issues during the fabrication of our mold. First, we used different tools for the finishing operations. For the negative part, we used a 3/16 ball mill, whereas for the positive part, we used a 1/4 ball mill. The reason was we wanted a smooth finishing and a shorter machining time for the positive part. Later, this caused the mold's part to not match properly. Second, we lost the position of the zero of the stock. When interrupting the machining operations or changing the CNC machine we were using in one of the machining sessions. This also caused the parts of the mold to not match properly.
After making the molds, we proceeded to make the electrical discharge machining process. At first, we designed a little elephant for this process, considering the minimum radii of the tools. But at the end, we decided to use a star that was already machined. We gave a very good finish. So the ADM process took like an hour. In this process, we were simulating the brand logo into the mold, so it won't be seen on the chocolate flower.
The process cycle for injection molding is as follows. Each half of the mold is attached inside the injection molding machine. When the mold is closed, the space between the mold core and the mold cavity forms the part cavity that will be filled with molten plastic to create the desired part. First, the molten plastic enters the mold through the sprue. The molten plastic solidifies into the shape of the desired part. During cooling, the material in the channels of the mold will solidify attached to the part, which must be trimmed. To have a better result, it's important to know the quantity of raw plastic material that will be needed. We used Fusion 360 to calculate the mass of the part. We confirmed that result by knowing the volume of the final part and the density of the polypropylene. However, we didn't add the volume of the sprue into our calculations, so we estimated this quantity and it was too much for our first injection process. After we reduced the quantity of polypropylene, we realized that the molten plastic didn't fill all the cavities, so we had to adjust the mold and the pressure. After making all these changes, we finally got our final product.
I think that the best conclusion I can give is that we could apply the theory in the practice, and with this project we can use this in the industry.
The first problem we got was dividing the activities and organizing ourselves to do it in time. Also, we didn't have enough time to be in the CNC when it was machining, but we organized ourselves the best way we could.
The way we faced this problem was by using the best skills of each one of us. We identified the strengths and the weaknesses of each member of the team, and we took advantage of this. And after that, we learned how to be a better team player and how to organize better our times and make good use of our resources.
Another problem we had was the availability of the machines at the laboratory. This caused us to have to take out the part and then use another machine for the next session of machining. This caused us to lose the location of the zero of the stock, and also the finishing was not as good as we wanted, but in the end we got around it. We solved this problem and we learned about our team, about our skills, and we can take away a lot of the technical background of this project into our professional lives.
Debajo del mar. Debajo del mar. I think that